And welcome back. As we go ahead and continue working with arrays, let's go ahead and take a minute to examine array parameters. So when we're talking about array parameters, first thing we need to understand is the index variable arguments. You can use both array index variables, or you can use entire arrays as arguments to methods, although they are different types of parameters. An index variable can be an argument to a method in the same way that any variable of the array base type can be an argument. So suppose we have a program that contains the following declarations: double n equals 0, double array a equals new double 10, int I. If you have a method, let's call my method, takes one argument type double, then the following would be legal: my method of n. Since an index variable of an array, though, is also perfectly legal to use, so if we say array a is also type double, then we could plug in my method a of 3. And that would be a perfectly valid entry for that method. Now, there is one subtlety that does not apply to index variables when they're used as arguments. So if we look at this method called my method a of I, if the value of I is 3, well, the argument would be a of 3. If the value of I is 0, then the call of this is equivalent to saying my method a of 0. The index variable expression is evaluated to determine exactly which index variable is therefore given as the argument. So there's one important thing to keep in mind here. So if we start plugging values in, it's also important to remember, like, are you going to, if you plug in, let's say, a of 0, you're not saying plug in 0, you're saying plug in the value that is at position 0 in that array. You can also define a method as a form parameter for an entire array, so when the method is called, the argument that is plugged in for this form parameter is an entire array. Whenever you need to specify an array type, the type name has the form base type bracket, so this is how you specify a parameter type for the entire array. So if we look at this method double array elements, it's going to accept any array of type double as its single argument. So in here you can see we have this method right here, public static void double array elements, double array a. Now, we are not defining it. It simply says this is what we're expecting is a double array. That's what this part means right here. And then this is simply just a placeholder local variable. If I had an array that existed outside of this method and I wanted to then pass it in here, let's say I had a double array, array 1. Then when I go ahead and call this method, I should be able to plug that in. So let's say we want to illustrate this a little bit. So suppose we have the following some method definition. So we have double array a equals new double 10 and double array b equals new double 30. And suppose that the elements of arrays a and b have been given values, so they're not empty. Both of these are then legal method invocations. Sample class dot double array elements a and sample class dot double array elements b. A and b here, of course, are these names that form these methods. You'll notice, though, there are no square brackets that are used when you give an entire array as an argument to a method. We're simply just plugging in the name of the array. Now, that does give us a little conversation about the length of array arguments. An array type is a reference type, just as any class is. So, as with a class type argument, a method can change the data in an array argument. To phrase a little bit more precisely, a method can change the value stored in index variables of an array argument. And as we just saw, this was illustrated by our method double array elements. An array type parameter does not necessarily specify the length of the array argument that may be plugged in for the parameter. The array, of course, already knows its length, and it stores that in the length instance variable. The same array parameter, therefore, can be replaced with array arguments of different lengths. And you'll take note, when we looked at the method double array elements, it could take in an array of any length as its argument. The most important thing, though, was that it was of the corresponding type. If I had tried plugging in, let's say, a string array, it wouldn't have worked. But if I plug in a double array, whether it's size 1, size 2, size 20, size 100, it's going to be a valid entry. Now, a quick pitfall to kind of keep in mind is the use of equals and equals with arrays. Array types are reference types. As we said, we treat them like objects. And because we treat them like objects, these contain memory addresses of the array that is being named. The assignment operator, when we use that, equals, copies this memory address. So if we look at the following code here, we have a double array A equals new double 10, double array B equals new double 10, int I for I equals 0, I is less than a length, I plus plus, a of I equals I. So we're simply just filling that first array with values. And then we're saying B equals A. So we're saying B equals A. And then we're going to print out the values of A of 2 and B of 2. And notice then we, of course, reassign A of 2 to 42. If you remember what we did when we did this with classes, you might already have an inkling of where this is going. Now, the sample code, if we were to execute it, would produce the following output. A of 2 equals 2.0, B of 2 equals 2.0, A of 2 equals 42.0, and B of 2 equals 42.0. Now, the reason why we see this is because the assignment operator, B equals A, copies the memory address from A into B so that the array variable B contains the exact same memory address as the array variable A. After the assignment statement, A and B, of course, are two different names for that same array. Thus, when we change the value of A2, we are also changing the value of B2. Now, unless you want two array variables to be two names for the same array, and there might be a rare occasion where you want to do this, you generally speaking should not use the assignment operator with arrays. If you want the arrays A and B in our code that we just looked at to be different arrays with the same values in each index position, then instead of using the assignment operator B equals A, you would need to use something such as the following. Int I, for I is equals 0, I is less than a the length, and I is less than b the length, I plus plus, b of I equals a of I. You'll notice here, we are not setting the entire array equal to another array. Instead, we're saying the value at an index equal to the corresponding value of the other index of that other array. And that kind of ties us back to our last bit here, which is equals equals with arrays. You'll note that the previous code does not make B an exact copy of A unless B and A have the same length. Well, that's because they'd have to be perfectly the same length. So the equality operator equals equals kind of relies on a little bit of a test here as well, because it does not test two arrays to see if they contain the same values. As we've already mentioned, arrays are references. And so when you use equals equals here, it's going to test those two arrays to see if they're stored in the same location in the computer's memory. And if we look at this code with two arrays, we have C and D here. You can see in this one, we of course we're filling C, filling D, and then we're going to say if C equals D, and we're going to say equals by equality, else we're going to say they're not equals. And if you had take a wager here, because we are filling these two values independently, and if you remember how we did this with classes, again, you might have an inkling of where this is going. Our sample code would produce the output C and D are not equal by equals equals, even though C and D contain the same integers in the same index variables. Like if you were to look at C of 1, it's going to be equal to D of 1. A comparison using equal equals will say they're not equal because, again, equals equals checks only the contents of the array variables C and D, which are memory addresses. And because C and D are independent from each other, they're going to contain different memory addresses. If you want to test two arrays to see if they're equal for the same elements, you can then define an equals array method for the arrays, just as how we've defined in the past an equals method for a class. Now over in Eclipse, we can go ahead and take a quick look at some of those methods. So here we have this C and D array that we simply just looked at. Again, you can see here we are filling those two arrays. Here we are going to test using a equals equals sign. And of course, we should expect it to say that they are not equal by equals equals. But down here, we have a equals array method. And you can see we're passing in C and D. C and D, of course, are referring back to the arrays. So if we look at the equals array method, down here you can see it's a Boolean, so that means that we're going to expect it's going to return either true or false. And right here we have two parameters. We have a int parameter for an array A and another int parameter for array B. And so these don't necessarily have to correspond to necessarily the exact same names. Remember, this is simply just a local variable name here, which means when I call that method, I could plug in C and D. And then inside of this method, it's pretty straightforward. We first look to see, are these the same length? Because if you know that the arrays are not the same length, well, they can't be equal because they have different lengths. And so if it fails that test, we automatically come back and say it's false. Well, what's if they are the same length? Well, we're going to come in here and say, well, if let's start I at 0, and we're simply going to traverse the length of I, and it's less than a that length. And all we're going to do is we're going to go through each element of both arrays, so A of I, and we're going to look to see if it is equal to B of I. If they are not equal, at any point return false. Otherwise, increment and keep going all the way up until we return true. Because if we return true, that means, of course, that the two arrays are equal. So let's go ahead and just give this a quick spin. And so if we test this out, we get C and D are not equal by equals equals. Again, we expect that because we saw that in our notes just now. And it says equals equals tests only memory addresses, which means, of course, that C and D are two arrays at different locations in memory. Then we get C and D are equal by the equals array method, because what did we notice about how we filled these arrays? We filled them exactly the same way. The only difference was this was filling in C, this one was filling in D. And so therefore we get the statement an equals array is usually a more useful test. So hopefully it gives you a little bit of an idea of how we might start being able to use some of these arrays as parameters, and also a little bit about how we might handle some of that testing when we want to see if they're equal or not.